start the new topic like the structural hazards. The structural hazard. Okay, now what's the structural hazard? Now assume a scenario. Assume a scenario that Fatma wants to talk to me and Jad wants to talk to me both at the same time. Okay, so can I have a talk or a meeting with you at the same time if you want to discuss different topics? So can I have a meeting with you and with you at the same time? No. So what kind of hazard is this? What kind of hazard is this? Structural hazard. Structural hazard occurs when there are two requests to a resource and that resource is not available. Again, another example. Let's assume Jude and Muhammad wants to print some document on a printer. A printer is now a shared resource. So can these two documents be printed at the same time? No. What will happen? First, even let's assume it depends on the priority. So maybe he sends his document first, so it's now being in print. When your document is being printed, the Jude document cannot be printed during the same time. So it means that this kind of hazard is called as what hazard? Structural hazard. And why structural hazard occurs in pipelining? So now we will explain that why, and please remember, all of the stuff that I'm going to explain will be included in your quiz 3, and it is not explained in my lecture slides. So this is important. Okay, they are there, but in a different context. But I'm going to do giving an example. So now we are assuming 4 instructions. Can you see the 4 instructions there? We are assuming 4 instructions. I1, I2, I3 and I4. I1 is in which color? Red color. Okay. Now we have different clock cycles. Now if you look at here, we have different clock cycles. So okay, now this is clock cycle 1. This is clock cycle 2. This is clock cycle 3. This is clock cycle 4. And this is clock cycle 5. Now look at clock cycle 4. Please remember this explanation is not there. Look at clock cycle 4. Now if I look at clock cycle 4, say thank you very much. Thank you very much. Okay, so in clock cycle 4, we are saying, I'm now in clock cycle 4. In clock cycle 4, which instruction is in fetch stage? I1 is in fetch stage. So I1 is in fetch stage. Which instruction is in decode stage?
Professor, it's clock cycle 4.
Yes, clock cycle 4, yes. I1 is in which stage? Memory stage. Now you're paying attention. That's good. Okay. I1 is now in memory stage. I2 is in which stage? Help me. Execute stage. Okay. I3 is in which stage? Decode. And I4? Fetch. Clear. Now look at I1. I1 is which instruction? Help me. Which instruction is I1? Look at the instruction. Which instruction is this?
LDR.
LDR. So I1 is LDR. And I4 is any instruction. It can be any instruction. It can be add, it can be LDR. I'm not interested in that. It can be any instruction. There is some instruction. I1 is LDR, and now we have an I4 instruction. And I4 is now in fetch stage. Now, if you're looking in LDR, so it means that I1, which is LDR instruction, requires to access the man memory. Yes? So LDR is what? Doing what? LDR wants to access memory. It can be LDR or it can be STR. It can be LDR or it can be STR. It can be STR. So it means that I1, let's assume we say that I1 is any type of load or store instruction. If I1 is a load or store instruction, it means that I1 want to access the main memory. Clear or not clear? Okay. But during the same time, I4 also wants to access the main memory. Why? Because can you see here, if this is any load or store instruction, if there is any load or store instruction, so we will have some MAR. What will be the value of MAR? Help me. Please remember, think in the context of pipelining. Samira. Yes, Muhammad. Yes, Umar. Yes, James. What will be the value of MAR? Yes. What will be the value of MAR? It means you're not prepared for your quiz 3. No. Please, remember. I1 is now in which stage? The memory state. Look at the block diagram. When some instruction is in load stage, what is the value of MAR? Yes, James. But very good. LU out 1. Very good. LU out 1. Remember? And what will be the value of MBR? What will be the value of MBR? The value of MBR, anyone may answer. This may be the question in your quiz 3. What will be the value of MBR? Either MBR will be LMD if it's which instruction? Load instruction. And MBR will be what? Help me. MBR will be B1 or B2? B2 if it's what? Store instruction. Remember, that's the reason that I'm doing a lot of practice. But if it means that you are not prepared for your quiz 3. I'm telling you are not prepared for your quiz 3. Now, again, now during clock cycle, now it means, okay, now during any particular clock cycles, now even if you are doing pipelining, during any particular clock cycle, there can be multiple instructions. There can be multiple instructions which are overlapped. So in clock cycle 4, there are 4 instructions which are overlapped. Okay. Now, during the same clock cycle 4, we need to fetch what? Which instruction we need to fetch? I4. So it means, okay, now it means that we are for LDR instruction. For LDR and STR, it means that LDR and this is I1. This is actually, this can be any load or store instruction. So let's assume the first instruction I1 is a load or store instruction. So it means that we need to access what? We need to access memory for data. For data or instruction? For load and store, it is in clock cycle 4. So now we are in clock cycle 4. We are in clock cycle 4. When we are in clock cycle 4, it is in the main memory stage. When it's in main memory stage, it means that we need to access main memory for data or memory. For data. During the same clock cycle 4, we are fetching which instruction? I4. So are we fetching an instruction? Because now I4 is in the fetch stage. So in the fetch stage, do we fetch the instruction or data? Instruction. Please remember, in the memory stage, what we are doing? In the memory stage, let's say we are in the memory stage. We are either loading data or storing data in the memory stage. But if you are fetching, what we are doing? We are doing what? We are fetching the instruction. Clear or not clear? So now please remember, this is important. So this I1 is now in the main memory stage. Please remember, this is now in the main memory stage. So we have the memory stage. So this, if the load and store instruction is in the memory stage, so it means that we need to access the main memory for data. And we need to access the main memory for data, so it means we need an MAR. And where is an MAR? And we did it in our last lecture, and that's the reason. Every lecture is important. Every lecture is important. If you are missing any lecture, every lecture is important. So we need an MAR, and then MAR, it will be, sorry, not LU auto, it will be LU auto. Now, during the same clock cycle 4, we are fetching an instruction. So okay, now we are in the fetch stage. Now we are in the fetch stage. Are we fetching instruction or data? Instruction. So we are fetching instruction. We are fetching an instruction. When we are fetching an instruction, so we need to access main memory. So what will be the value of MAR? Help me. Whenever we are fetching instructions, we need an MAR. What will be the value of MAR? PC, program counter. And what will be the value of MBR? Yes, what will be the value of MBR? Remember, MBR is connected to what? Because MBR is connected to IR. Because whatever is the content of MAR will go to MBR, and from MBR, where will it go? IR. So it means that actually IR, then it means we are loading IR and then MBR will be there. Got it or not got it? Any question? So okay. Now, please remember, here, if you are loading instructions, so LND on the left hand side, because we are loading the instruction. So can we see here? So now we can say LND will have the same value that is in MBR, because we are reading the main memory. And here, are we reading the main memory or writing the main memory? For store, we are writing, so we are storing B2. Got it or not got it? And that's also the direction of the data. So let's see, if I'm saying, Muhammad and the key, please come here. I'm reading or I'm writing? Reading. And that reading, where did it go? LMD. And if I'm saying, oh, please sit there, so I'm changing the new value. So if I'm asking Jude to sit here, so it means I'm changing the old value and writing with the new value. Got it or not got it? So in this case, MBR will be what? Any question? Now there is a problem. It means that now for I1 during clock cycle 4, we need to access the data for LDR, and during the same clock cycle we need to fetch the instruction. So this kind of hazard is called as which hazard? Structural hazard. You got it or not? So it's the same example. Fatma wants to talk to me. I'm the man memory. So this is LDR. Maybe this is Fatma. And now during the same clock cycle 4, this is Jad. Jad wants to fetch the instruction. Fatma wants to either load or store the data. And this is a poor professor. Only one guy. So it means, what kind of hazard is this? Structural hazard. You got it or not got it? How can we avoid this problem? So let's assume Jad wants to talk to me and Fatma wants to talk to me at the same time. Can we do it at the same time? How can we solve this problem?
Separate clock cycles.
Either separate clock cycle that will create a stall. Can we? Yeah, either we have to stall Jad. Okay, if I'm talking to Fatma, it means I will ask Jad, please wait. If I'm talking to Jad, it means I will ask Fatma to wait. So it will create a stall. Stall is good or bad? Bad. How can we solve this problem? So instead of having one professor, we can have two professors. One professor will talk to Fatma, other professor will talk to Jad. So can we do it at the same time? Yes. So it means that now we have divided, now we have not have one memory, but how many memory can we have? We have two memory. So it means that we need to have a separate memory for instruction. So it means that we, during this time, so we access this data from which memory? Instruction memory. And we access this data at the same time from which memory? Which memory? Data memory. So now we avoid this problem. And if remember and again, why there is a reason for two memories. And then if you look at here, so now if you look at here, in the example, in the classical pipeline example that we did it here, so can you see here, what is this memory? Instruction memory. And what is this memory? Okay, please remember this, and again, so can you see here, this data main memory is connected to the address line through what? ALUOUT 1. This data main memory is connected to the data lines through what? P2 for store instruction and LMD for load instruction. You got it or not got it? Okay. Again, now if you look at here, what kind of memory is this? Instruction memory. And this instruction memory is connected to MAR through what? The program counter. What? Because program counter stores what? The address or the data? Address. And this instruction memory is connected to the data lines through what? IR. Can you see here? Any question? Any question? So now this is the complete picture. This is the complete picture. And you need to know the complete picture. Any question? Okay, so now, now please remember. There are two ways to solve this problem. Solve this problem. So now what I'm going to do, so basically I'm now going to rub this up, and maybe this is the question in your quiz 3. Maybe this is a question in your midterm 2. Maybe this is a question in your final. So please be attentive, and please, I will never ask any question that I didn't solve it in the class. And most of the questions that I ask in my class, they are not in the lecture slides. Okay, so what I'm going to do, so now, okay, now, if you want to solve this, let us assume, we have only a single memory. We don't have any two memories. What will be the problem? Let's do, okay, now in this case, we have solved this problem. What we can do, we have solved this problem by having a separate instruction memory and separate data memory. Now we have solved this problem. We have solved the data structure problem. Because now what we are going to do, we are performing a load and store operation on the data memory, and we are performing the instruction fetch memory on instruction memory. So we have already the problem. But let's assume if you do not have a separate instruction or data memory and we have a single memory, what we need to do? We introduce to what? A stall. So when we introduce a stall, so what we can do? So we can introduce a stall there, because we cannot continue this at the same time. So let's say we have the same memory. So we have I4. So we do not do I4 and then we say S stands for stall. So this is a stall. We call this NOP. This is called as NOP instruction. So it means that the NOP instruction is now fetched. We call this as NOP stall. Because this is a stall. Clear? Okay. And then we need to have an I4. And then what we need to do for I4? I4 is fetched where? In the next class. And then you just fetch, decode and execute and man memory and write back. So it means that if we do not have, okay, now there is $1 million question. Will there be a stall? So now when there will be a stall, and this is $1 million question. So let's assume, okay, now, okay, assume this will be the question in exam. So this is the question in exam. Question number 1. Assume that we have a combined man memory. Assume that we have a combined man. We do not have separate man memory. When, part A, when we will have a stall. What is your answer? Anyone who will answer this question will get 1 bonus mark. Anyone who will answer, and please give me a generalized answer. Anyone who will give me the answer to this question will get 1 bonus mark. When we will have a stall, because now we have a combined memory. When we will have a stall. Yes?
When instruction memory and data memory are overlapped in the same class.
Yes, but when? So can you give me, yes, when main memory and when memory. So basically this is very important. Because okay, now please look at here. What is the difference between I1 and I4? The number of stages. How many stages the difference is there? 3. So it means that if, so we can say, okay, now please remember, now this is my I. Let's say I'm saying this is my I. This is my I. What is I here? I is 1. What is my I here? 2. What is my I here? 3. Can I write it here? I. Then tell me I plus what? Plus 1. Then I plus 2, and then I plus what? 3. So it means that if I is a, okay, now or we can say, please remember, if I is a load instruction, if I is a load or store instruction, okay, there will be a stall, we will have a stall. If I is a load instruction and we will have, okay, if I is a load instruction, and let's assume in that particular clock cycle, we are in clock cycle K, let's assume we are in clock cycle K. It means that during clock cycle K, if I clock cycle K, we are any particular clock. So in this clock cycle, this is now my clock cycle 4. I will call it K. Let's assume in any clock cycle K, we are performing a data operation on I during the same time. We are performing what? We are fetching which instruction? Huh? I plus 3. Then there will be a star. Okay, when, okay, again, in which scenario there will be no star? Yes, it means in that particular clock cycle K, we do not have a load or store instruction. Okay, assume again. This is a question, and this may be the question in exam. Please remember, this is a question in exam. Assume this is a question in exam. So what I'm going to do, this may be a question in your quiz 3. Anyone who will solve it? Okay. Question in exam. Question number 1. Assume there are 1000 instructions. How many instructions are there? 1000 instructions. Okay. There are 5 stages in a pipeline. There are 20% of load and store instructions. What will be the speed up? What will be the speed up compared to non-pipeline machine? Your time starts from now. Please try to solve it and please show me your answer. Please show me your answer, because the reason is